All right, 1, 2, 2, real and complex zeros. Find the zeros for each of the polynomial functions. Confirm it graphically on Desmos. Oh, I know how much you guys love these guys. All right, so let's do A over here, and we'll do B over there. X to the third minus 3x squared minus 4x plus 12. All right, so what I need to do first is find out if there are any rational zeros. They're going to be multiples of the constant coefficient. So 1, 12, 2, 6, 3, 4. And I'm going to go ahead and just do some quick synthetic to check it out. So let's go. Start with 1. That's easiest. 1 times 1 is 1. Negative 2. Negative 2. Negative 6. Okay, not that. Let's try negative 1. Negative 4. Positive 4, 0. 0, 12. Okay, well, that's closer. Except my 0 came too soon. Let's try 2. 2, negative 1, negative 2, negative 6, negative 12, 0. Haha, we've done it. So that means that x minus 2 is a factor. And that leaves us with x squared minus x minus 6, which I can factor to x minus 3, x plus 2, which gives us our zeros at x equals positive 2, x equals positive 3, and x equals negative 2. And I can check that by going back to my graphing calculator. And again, I'm going to go y equals. I'm going to go ahead and clear that. I have x to the third minus, oops, don't want that in the exponent section. 3x squared, 4x, 12. Minus 3x squared minus 4x, right? That was a minus. Yep, plus 12. Graph. There's my graph, and I can see the zeros. And another cool thing I can show you on your graphic calculator is that you can actually find the zero exactly. So what I'm going to do is I'm going to hit, let me go ahead and change this window a little bit. So negative 10, 10. Let's go ahead and change this to negative 50. Positive 50, and see. Oh yeah, that's better. And then I'm going to hit this trace button. And this trace button allows me to just move along the graph and see what the point values are. Okay, so, but there's another feature here too, which is right above it, which says calc. So I'm going to hit second and then the trace button again. So it says calc, and I want to find the 0. So now if you look at the bottom of the screen, it says left bound. So I want to go to the left side of where I think there's a 0. Should be here. Press enter. And then I'm going to go to the right side of where I think there's a 0. And press enter. Nope, that's not enter. There we go. Oh, buddy. Clear. Go back to the graph. Let's try that again. Second. Calc. 0. Left bound. Here. Right, to the right of where I think there's a 0, which would be there. And then it says guess. Yeah, I want you to guess. 0 is negative 2. Negative 2, comma, 0. Okay? So then I want to do it again. So I'm going to hit second calc. But this time, my left bound is going to be here. And I'm going to go, it looks like my next 0 isn't down until here. So I'll put it right where my y is negative again. Enter, guess, please, to 0. Okay, so that's how you can check where your zeros are on the calculator. All right, next one. X to the fourth minus 5x squared minus 36. So this is one of those special ones where it's a 420. So I'm just gonna use another color because this is what I did in class, where I write x squared minus 5x minus 36. And I'm going to factor that. So two numbers that multiply to negative 36 and add to negative 5 are 9 and 4. And in this case, 9 is going to be the negative number. So this would be x minus 9, x plus 4. Okay, but instead of them being linear terms, they're going to be quadratic terms. So this is x squared minus 9, x squared plus 4. And this I can factor again because it's difference of squares. So x plus 3, x minus 3, and this is still x squared plus 4. Here I get x equals negative 3, x equals 0, and then this is a sum of squares, which means that it has two imaginary solutions. And those are not real zeros, so we're not going to see them on our function. Okay, so our zeros for this function are negative 3 and 3. And then I'm going to have two imaginary solutions. So you would check this on the calculator the exact same way, plug in the equation, and then use the trace button. All right, find the zeros of each of these functions. All right, 0 equals x to the 4th minus 25. So this is a difference of squares, and that would factor to x squared minus 5 times x squared plus 5. And here we would get x squared minus 5 equals 0. Add 5 to both sides, and x is equal to plus or minus the square root of 5. Not pretty, but an answer. Still an answer. Over here, we would get x squared. This is a sum of squares, so these are going to be imaginary. X squared equals negative 5. X equals plus or minus the square root of negative 5, which is plus or minus I root 5. So those are our 4 answers. Remember, you would have to have 4 answers because it's to the 4th power. And we do. We have 2 here. We have positive and negative, and then positive and negative here again. All right, next one. X to the 3rd minus 2x squared plus 5x. So the first thing I'm going to do here is factor out an x, and that leaves me with x squared minus 2x plus 5. So I'm looking for two numbers that multiply to be 5 and add to negative 2. Sad face, there are none. Which means I'm going to have to do the quadratic formula, which is just, do I have to? Just don't want to, but I will. Okay, just for you guys. I'm only doing it for you guys. Oh, and this is 0. X equals 0 here. Okay, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, x equals, so negative 2 is positive 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 5, which is 20. Oh, this is actually not that bad. It's going to look bad, but it's really not that bad. And I'm out of space, so I have to go down here. So this becomes x equals 2 plus or minus the square root of negative 16 over 2. Well, the square root of negative 16 is 4i, so this is 2 plus or minus 4i over 2. Both things I can divide by 2. 2 divided by 2 is 1, plus or minus 4i divided by 2 is 2i. So those are 2 more solutions. So we have 3 solutions, right? X equals 0, and then x equals 1 plus or minus 2i. Find the polynomial function f of x with the real coefficients. So something of degree 4 and has those zeros and a leading coefficient of 1. Okay, so my zeros, just so I can write everything, is negative 2, 3, and negative 1 plus I. If it's negative 1 plus I, then negative 1 minus I also has to be a solution because complex numbers come in pairs. So this would be x plus 2, x minus 3, x plus negative 1 plus I. Or sorry, that's a minus. Always a minus. And x minus negative 1 minus I. So I'm going to deal with these two things first because they ugly. So this would be x plus 1 minus I times x plus 1 plus I. And I need to multiply those two things together. So x 1 negative I. X 1 I. X squared x xi. X 1 I. Negative xi. Negative I. Negative I squared. So what happens here? Thankfully, lots of things cancel. So this cancels with that, and this cancels with that. And here we know negative 1 I squared is really negative 1 times negative 1, which is positive 1. So this whole thing, despite being super ugly, goes down to x squared plus 2x plus 2. Okay, so that's that one. And this one here is x squared minus x minus 6. So the two things I have to multiply together now are x squared minus x minus 6 and x squared plus 2x plus 2. Which, again, I'm running out of space. Man, Cited, you're really not doing well here with the space. All right, so we'll do that there. And then let me move. Oh, no, it's going to do that. I don't want to do that. I'll just move that over there. And then I'll move this. Shh. Maybe if I don't scare it, it'll work. There we go. Beautiful. Okay, so now I can multiply these two things together by my pen. Whoops, this is a third. Negative x cubed, negative 2x squared, negative 2x, negative 6x squared, negative 12x, negative 12. All right, so finally I get my equation. So notice things on the diagonal are the same. Those are all like terms. So I get x to the 4th plus x to the 3rd. Negative 6 plus negative 2 is negative 8 plus 2 is negative 6 minus 6x squared minus 14x minus 12. That is our equation. All right, given this, find the degree of the polynomial. Easy. 3 plus 2 is 5. Discuss the behavior at the x-intercepts. Oh, well, these are repeated solutions, right? So if I have 1 minus x to the 3rd, that's a repeated solution, so it's going to bounce there. And 4 plus x is also a repeated solution. So at the x-intercepts, the graph touches the x-axis but does not cross the axis and returns in the direction it came from. Hashtag it bounces. Find a polynomial function f for which 2 is a 0 of multiplicity 2. That means it's repeated 2 times, so x minus 2 squared. And root 5 is also a 0. Okay, so x minus root 5. Boom. You want me to find a polynomial, so you want me to multiply those two things together. That's really actually quite ugly, but if this is true, then you know what else is true? X squared minus 5 is a solution. Because if I were to solve that, I would get x squared equals 5 and x equals plus or minus 5. And this isn't saying of least degree, okay? So what I did was I introduced a new solution here by changing it from linear to a quadratic. It just says that root 5 is also a 0. It doesn't say anything about negative 5, and it doesn't say that I'm looking for a least degree polynomial, so I'm going to go ahead and use this because I know it's going to work. So I have x minus 2 squared times x minus 5 squared. X minus 2 squared is x squared minus 4x plus 4. X minus 5 is x squared minus 10x plus 25. And now I just have to multiply these two guys together. X to the 4th minus 10x to the 3rd, 25x squared, negative 4x to the 3rd, 40x squared, negative 100x, 4x squared, negative 40x, and 100. Again, the diagonals are going to be the same, so I get x to the 4th. Combine these two. Minus 14x to the 3rd. 4 plus 40. Let me do this. 40 plus 25 is 65. That is notes from a long time ago. Which you don't need to see. 65 plus 4 is 69. Minus 140x plus 100. And that is our answer. Find a polynomial f that would match the graph of the polynomial function in the following figure. So really any function. What we want to look at is these zeros. So here we know our factor, if that's negative 2, our factor is going to be x plus 2. Here that's just an x, right? X plus or minus 0, it doesn't matter which one you use. And this dude is a bounce. So that means it's going to have 5 twice. So it's going to be x minus 5, but there's going to be 2 of them. At least 2. It could be 3, but at least 2. And it's saying a graph that would match a polynomial function. Not the polynomial function, a polynomial function. So x plus 2, x minus 5 squared. Again, we're going to multiply all this out. So we get x squared plus 2x times x squared minus 10x plus 25. Sorry for the people that hate the box. It's just way easier when you're doing these long ones. which gives us x to the fourth minus 8x to the third plus 5x squared plus 50x. All right. The function over the domain negative 10 to 10 is represented for selected values of the table. Give f of x, given that f of x is an even function, complete the table. Okay, so even means that it's symmetric about the y-axis, right? So if something's an even function, it looks like this. So most likely symmetric about the y-axis. So if negative 10 is 18, then 10 is 18. If 4 is negative 3, then negative 4 is also negative 3. And if negative 1 is 2, then 1 is 2. So it should look like that, because it should be right across, if it's even function, it's symmetrical across the y-axis.